I've got a phone today. This is a Teledex Diamond. The 10M has to do with the buttons, the amount of buttons they have on it. I really can't find too much more information on this. I don't know how old it is. The Diamond model is still in production, so any search for Teledex Diamond shows all of, every model they ever made. So I'm hoping that inside we'll be able to find a date code on a chip or something like that, and we'll be able to figure it out. I'm suspecting early 2000s, 90s maybe, This was part of this was in a facility that we moved into, and there was literally a heaping pile of phones in a room just thrown on top of each other. And we ended up throwing pretty much all of them away, but I kept some around for, at the time I was doing some voice over IP Cisco training, so, kept them for that. So anyways, I'm looking at this thing, and I guess this is kind of like common to the things that I'm starting to grab, or maybe the things that you might be wanting to, tear down, rip into, if we're going from the point of view that we want to get something out of it. Of course, we can learn stuff from everything, and so you should tear down all the things. But if you're trying to get some stuff, these kind of items here might be kind of good. So, we're looking at this, we got a handset. Maybe you want to keep the whole handset. Maybe you want to make a weird-ass walkie-talkie project. That could be cool. If not, we get a mic and speaker. There's a speaker inside the, the cradle thing here. Switches here. These are pretty nice buttons here. They feel pretty good. So I'd try to keep this matrix pad in here. It's, I don't know, is it going to be all or one? I guess we'll see. But anyways, that's about all I can see. A cord, RJ11 cords, they're grown, I guess. So let's flip this thing over, we'll tear into it, and I guess that's job number one, is see how we can tear it apart and see what it's got inside. Alright, I'll go ahead and get this out of the way for now. So will we? Whoa. Yeah, we'll probably bust in this later, but it kind of looks like it's going to be, oh, it's just going to crack apart there, yeah. So we'll get into this in a minute. Okay, we got some wires connecting some things. Oops, oh my god. Okay, well, here you can see this board is all one piece. I think I'll try to remove this board from here. Yeah, and nothing is, it's all just soldered right in there. So I'll figure out what's going to be the best way to deal with this. Probably this. Alright, well, I think that is it. Hopefully we don't lose everything. Oh, I hear things falling, so that's the buttons. Bummer. Well, oh, it's just a pad. Huh. They felt really good for being a pad, so I guess that's a new thing for me. Interesting. Somewhere in the combo between here and there, it actually felt not quite like mechanical, but it felt like there was a click. Bringing myself a little garbage bin in here, so this is gonna be a lot better than the normal mess I've been making. Okay, so I'll have one up here for garbage. This will actually go into the garbage. And I mean, I really doubt I need these screws, but I'm going to hold on to them just for a little bit. Then maybe I'll grab another one for good stuff. Okay, I think I can just take the board straight out. I don't think there's anything that's got to come out. This is not flush with the outside, so everything should just lift up and out. I think it's lead. So what I'm thinking is it's to balance the thing. I'm thinking that it's too light when you sit it maybe on the wall or in some orientation here. They want it, you know, to swing down. So I think it's weight. So yeah, I'm gonna go ahead and keep these little guys here. They do appear to be lead. You know, maybe I need to go consult Cody's lab to find out for sure. But I'm gonna go with they're heavy, they're kind of soft, and I was able to snip off a little bit and melt it. So I'm gonna call it lead for right now. I could use this in a couple different places. So I think that might be a date code right there, the 4th week of 1998. That's probably about what I expect for these things. I'll look around. There might even be just a date sitting out here somewhere. So I think this looks pretty good. This is probably a reasonably decent find, I guess, as far as, you know, collecting some things and learning a few things. So down here it looks like, I haven't looked any of this up yet, but it looks like some 74 series TTL stuff. Over here, little chippy, you gotta figure out what that is. We got a little transformer right here, caps galore. What else of interest? A little battery. What is that? Is that a mauve? I don't know. I guess we'll see how my brain is learning or not. You know, because that seems like thermistors, NTC, mauve kind of stuff for input resistance or input spike in dealing with that. But I could be totally off base there. Yeah, probably. Some kind of chippy here, transistor everywhere, a little switch. I don't know if that's, yeah, that might be cool. But you notice here, not a surface mount component to be found. So that's pretty interesting. So that's you know, that's pretty old. Like this is maybe 1998 here. The board might have been created a little bit earlier than that. So for starters, as kind of a reprieve on the last video, learning how to get my rework station to work right, I think I'm gonna try just warming up. Oh, this is gonna be a fail. Well, I'm gonna try warming these up with the heat gun and seeing if I can just pull them out like that. That just doesn't seem like that's gonna work. Yeah, the solder sucker, you know, I mean, that's probably going to be what I'm going to use for this, but let's give that a try. Heating up. Okay, so we're going to bring this thing up to pretty damn hot. Okay. I'm at 390. Last time I left the last video at 380. I was doing a lot of lead-free stuff, and so this should fare pretty good. So I'm kind of pulling on the cables here, and I'm holding some pressure here. I think this is probably standard issue for most electronics. Trying to hold things with your toes while you work on something. This might be pretty good. I think I felt it kind of give way already a little bit in spots. Alright. Hey. So, all in all, I didn't melt the cable too bad. What is the... Oh, wow, what is goop? What is this? Some kind of... Ew. Shmoo glue. What is this? Oh, that's the Celastic from the other side holding in... Yeah, it's booger snot. It's hot glue. Yeah, yeah, smell that? Smell it? Mm-hmm. Ew. Okay, so that worked out pretty good. That wasn't terribly too far off from the time it would have took with the little fart machine, the solder sucker. So anyways, it gets this out of the way for right now. Now I can start to attack all the other components. So this speaker, I need the glue out of the way, but we'll go ahead and just take that. So we need a speaker like this nowadays. We'll save it. The rework station works okay. It came out. The place stinks like old, you know? Old yuck. You know, I'm not really liking it, so we did it, got it out, but I'm going to try the rest of this with the solder sucker. I do want to mention, look how nice and shiny and new this looks. This is, I mean, I could be terribly wrong, but this reminds me of, I don't know if it was Bakelite or whatever, but the old, really old electronics, like 60s, 50s. So right off the bat, I got a little bit of stuff here. So this is, it's a little bit beyond me right now, but I'll explain sort of what I got. So this is a 74HC, 74HC14. And what I figured out is that's the way you're supposed to read this right here with this HC in the middle here. If you look that up on Wikipedia, you'll find out that the 74, the HC part is a little bit of code explaining what it is. In the old days, this might be just H for high speed, but nowadays it's HC because this is high speed CMOS. So this is not the TTL logic of the old days. This is something, you know, well, newer than that, you know, but so the 74, apparently if it was the 74HC04, it would be in hex inverter. But this being a 1-4 makes it an inverting Schmidt trigger inverter, if that's the way you say it. So, and they say it's hex, right? And so my first thought was like hex, like hexadecimal, but no, it's hex as in 6. So it's 6 inverters. It's kind of like, you know, a dual H bridge. It's got a couple in there, or full H bridge. So, anyways, that's the 74HC14 inverter. So then if you look at this one right here, this is a 74HC74. And if you look that up on the Wikipedia 7400 series logic kind of database they have there, you'll find out that this one here is a dual D-type flip-flop. And again, a little bit beyond me right now. The idea behind these videos and things is I'm going to kind of call it as I see it, and then I'll probably post up on the screen when I have a little bit more information. But I'm guessing that that the flip-flop here is storing some little bit of information from, or to, or whatever, from the inverter over here. Now, the thing I'm not really certain of is why inverters, you know, what the sense of inverting a signal is in this case. I get what they're supposed to do, but how does that help? I'm not certain. So I'll think about that for a while. This is probably nothing that will come out in this video, but when I find these little problems, it become little things in the back of my head that I kind of research later. So then if I look in the back here, I can see that some of the traces, a good portion of them from the inverter, are heading over to the flip-flop. So they do seem to be working together, I guess, as you would imagine, with them being set right next to each other. Let's try the desolder gun here for these. So it looks like right here. Yeah, doesn't get much better than that. This switch is pretty interesting. I don't really see how it works. So let's go ahead and take that one off of there. And let's get this cable out of the way too. Oh, running a little hot. Is that it? Oh, I got these little stakes right here. Having some reasonably strong fingernails, I guess, helps. Whoa! All right. Oh, that's all right. It's that completely self-contained little bugger. Huh. Well, we'll save that. I'm not sure what you would use this for. Well, you know, maybe you'd cut it off and redo something. I don't know. It's a turtle. How about we get the transformer? Oh, we got a little elastic holding in there. Some kind of hot glue. Don't need that. This is interesting. Don't really know how to tell what this is. Okay, I'll look online. I'm sure there's a way to check something like the difference in impedance between the poles. I'm working on pulling off the rest of these capacitors, and I wanted to mention this. If any of you don't watch, I mean, if you've never ever watched an electronics video in your life, then you probably don't know what this is. But if you have, you know that this hot glue, elastic, any kind of this kind of a gunk that they use on here, the capacitors here, these components haven't exploded. They just use this here to hold these in place, because the thing to remember is that everything vibrates, everything shakes. Even if it's sitting still, there's some kind of small oscillation. And if you have anything that's got a little bit of a weight to it, obviously they don't think that the transistors were an issue, but anytime you have like a cap here and it's sitting up, and if it's vibrating, it has this ability to wobble around and eventually crack the solder joints free. So I guess it's been kind of known from what I've seen watching other reviews or repairs, is a lot of times broken components, the number one thing is either blown up, dried up caps or wobbled free ones. And so then you just desolder, or you mean you just kind of reflow everything, solder all the joints again, and you might end up with a working device again. I'm looking around trying to find what other interesting thing I should take off next, and kind of trying to test myself and see if I remember what any of this stuff is. And I mean, these here, they look to be ceramic caps, but I feel that there's something different. I don't know if, they get kind of a lump on them, so maybe they're an NTC or PTC, positive or negative thermal coefficient thermistor. This one here is speculating that it's a mauve, and I mean, sometimes, I mean, they look a little bit more like a piece of popcorn or a piece of corn, but I was thinking it might be a old dipped tantalum, but then I noticed right here mauve, so that's a metal oxide varistor. So maybe we'll rip those out. Do I need that? I don't know. Yeah, let's grab them anyways. Part of the other thing I'm doing, I don't need the caps, but I wanted to get them all out of the way. And the other thing is the little fart machine right here wasn't, it was all clogged up, and so I kind of want to just make sure it's working and, you know, just keep desoldering stuff. So I just wanted to explain a couple more things here. This one was really difficult to figure out what the how the markings were listed on this. So as it turns out, it's written basically like a capacitor. So the 301 is not 301, and it's not K. There's not ohms. The K ends up being a tolerance value. It's 30 with one extra zero added. So it's 300 volts. And then the K is, at most places, seems to be about a 10% tolerance. So this ends up being a 300 volt varistor, as in it will break down at 300 volts. There'll be another rating in the datasheet on when it will, basically explode. And also on top of that, if you're constantly twitching it right at the edge, if it's constantly breaking down and you're using it as just kind of like to clip things, that are happen fairly regularly, it does sound like that it will wear out, essentially. I'll do a little bit more house cleaning to get rid of these RJ11s. Yeah, I might keep these. No. So, I know, well, as much as I know anything, that this is a cap right here, C8. And you see these around, but the thing is just, the package that we have here, I see this in lots of old devices, but I mean, I don't know. It's not made the same as all the rest. Is it ceramic? I don't know, so I have to look that up. Yeah. Now these little guys here are inductors. You can pretty much tell from the way, it looks like something might be wound there, and we've got L1 and L2 right there. So I'm going to keep those. Those are always nice to have. Oh, and remember, this one was fine, but inductors, when you're holding onto them and you're desoldering them, you're holding right onto the coil. I mentioned this in one of the last ones. Whatever, they get hot. Oops, wrong bin. Yeah, it always seems like having a good old mechanical switch around is good. So I was looking around at these diodes here, and these ones, you know, as far as I can tell, look to be general purpose. It's possible that they could be Schottky diodes, but they look like the typical diode. By the way, that wasn't me, so that's some kind of crap solder there. But then these little guys here, they kind of remind me of a Zener diode, but I know they're sort of different. So I looked them up, and you know, well, of course they're extremely popular. I didn't know the name of these, so they're I don't know if you can see that on here, but it says T4148. Yeah, let me see if I can get it up there. Whoa, that actually kind of focused. T4148, otherwise known as an IN418, and it is a signal switching diode, and glass passivated diode, or a point contact diode. So anyways, one of the most common made, the 4148 most common made signal diode. So the big deal with these is that well, they're a little bit lower rated for the voltage and the current, but they can handle a lot higher frequencies than, say, your general purpose. So in high frequency applications, this might be the one you're after. Okay, so this one's a little bit different, but I'll show you here. This is the one I was going to go after. If you take a peek, I don't know if you can see it that. But anyways, the schematic's a little bit different, and it does appear to be a Zener. This is a thing that I find is kind of interesting, though. Let me get this ripped off and I'll show you. The logo is always backwards. I see the logo forward and backwards. I've seen people write it different ways, and it's kind of damn confusing. But, I mean, for everything I've seen, that looks to be a Zener. It is now pretty toasty Zener. Oh, what the crap, I still can't get that out of there. You can kind of tell in here, they bent the crap out of the leads. So, well, while this is sticking up here, see, there you go. So you see that? It's, I mean, it's not a Schottky, you know, so it's definitely not got that, but, I mean, as far as I can always, whatever, I guess I'm not going to quibble over, but you always see this going backwards the other direction. Well, it seems. I guess this is more of the truth than the book, right? So yeah, this is a Zener diode. This is a 1N4760, and that number ends up going all together. It pops right up. First thing on the list is the data sheet for this. So this is a planar Zener diode. So it turns out we have another weird looking one over here. So let's get this one pulled out. I'm kind of curious. You can see the schematic down there in ZD1. That doesn't look like anything I've seen before, but you know, I am not the authority on things. BZX or something? Yeah, let's rip that out. 5V1 BZX. Oh, look at the poor little lonely mystery device. We better take him too. For my big finale, I have this last little chip here. This one here doesn't look like much, and maybe it isn't very much, but what it is a ringer replacement IC so that it can make the little noises for the phone to replace the old school ringer of the antique phones. Now it has a low frequency oscillator and a high frequency oscillator in it, and what I'm hoping is that maybe I can play around with this and get it to make some noise. Maybe I can vary the tone a little bit, because phones, I feel that all phones were designed to kind of be able to change the tone. Maybe, maybe not. So anyways, it'll be a fun project down the road just to see if I can get it to do something. Well, I think this one went pretty well. This was a lot better than some of the last ones, but I feel like I'm still getting my legs on this concept here. But I am feeling like I'm learning a lot, and so that's what's important to me. What I hope that maybe you guys get out of this is, you know, you're learning some stuff about components, and that's good too. If you're experienced at this already, I really don't think these videos are going to be, you know, of any good for you. Maybe from, you know, take it from a quiz kind of standpoint of like, do you know what that is? Do you know what this is already, you know? But for the most part, it's me learning things, and then maybe I'd pose this to you guys out there. Do the same thing yourself. Go find something, and you know, you don't necessarily need to start up a YouTube channel, but sure, you know, but go find a thing, and here's what the detail is going on. Here's what's happening in the background. I go find these things, and then somewhere up here I post a little thing that says, hey, this is what this is. Well, in order to do that, I have to go spend, you know, over at the computer there a bunch of time researching all of these little things and figuring out what they are, how they work, and getting the best data sheet, you know, the best thing, you know, because if I can't find it from the source, I got to find it from like all data sheets or some BS like that, and put it up on the screen. So it's a little bit like, you know, when they say take notes in class, you know, because you write it down and you remember it even if you never read your notes again. Sort of something like that. So go through that. Find something around that you don't care about. Tear the whole thing apart. You're going to throw it away anyways, right? So open it up, get into it, see what's going on in there, take the components out for the experience of the whole desoldering and reworking and touching and, oh, ouch, that burns when you do this. It's all good. The whole entire process seems to be a pretty good, solid thing. So that's kind of the focus on here. I could have spent a little bit more time on some traces on this one and maybe understanding, you know, a little bit how the circuits work. But for right now, I think I felt, you know, like I just wanted to get through the components and study those. You know, there's always you know, just an infinite amount of detail we could spend learning from one board. And oh yeah, don't forget over here we had our little membrane, or not membrane, but our little touchpad we had. Didn't do anything with the handset here, but that's just a speaker and a mic, and you know, and that was it. So next one coming soon.